cast rule. In quadrant 2, sine is positive. But hold on, is this sine? No, this is cos. And this makes sense because cos was actually negative here, which makes sense because we expect cos to be negative. So now we have to figure out which other quadrant is cos negative. Is it quadrant 1? Well, no. Quadrant 1, all of them are positive. Quadrant 2, we already drew our terminal arm. It's either between quadrant 3 or quadrant 4. And cos is negative in quadrant 3. And be careful when drawing a triangle. Do not draw a triangle like this. That is the most incorrect thing you could do. You always draw a triangle like that. Technically, they should be at the same spot, but I obviously didn't draw it 100% symmetrical. There, close enough. Now, what's the angle inside here? Well, we know that the principal angle is 109.5 degrees. We know the angle from here to here is 109.5 degrees. So how do I find the angle on the inside? Well, remember, the key point is 180. The whole thing is 180. So if I do 180 minus 109.5 degrees, well, that should give me the angle inside, which is 70.5 degrees. If the angle inside of the first triangle is 70.5 degrees, well, guess what? The angle on inside this triangle is also 70.5 degrees because they have the same related acute angle. And if that's the case, well, I know then that the angle that goes from all the way here to here has to be 180 plus 70.5 degrees, which is 250.5 degrees, and that's the answer. So these are my two answers, and you can check your answers. You can do cos of 109.5 and cos of 250.5. Plug it into your calculator, and you should get the exact same number. And here we have 109.5, 250.5. So perfect. Okay, so tomorrow is going to be a way too much stuff for me to handle. But yeah, it just means you guys will have to watch all the videos. But we are going to do lesson 4. In my notes, we've completed lesson 1 and 2. Today we're doing 3, and hopefully we'll complete 4. And then tomorrow we'll do 5 and 6, and then review. If we finish lesson 4, that is. Alright, so lesson 4, we're going to talk about now reciprocal trig ratios. Reciprocal trig ratios are basically your primary trig ratios, except they've been flipped. And what do I mean by flipped? I mean reciprocal. What do I mean by reciprocal? Well, I mean flipped. Hopefully you remember what a reciprocal is. It's when you kind of flip the fraction. So what does that mean? Okay, so we got everything here now. So here we have sine theta, and we know sine theta is opposite over hypotenuse. We know cos is adjacent over hypotenuse, and tan is opposite over adjacent. Pretty straightforward. Now you're going to be introduced to 3 new trig ratios, but they're not really new. They're related. So cosecant, which is going to be CFC, is the opposite, or sorry, no, I apologize, not the opposite. It's the reciprocal of sine. So cosecant theta is equal to 1 over sine theta. What does that mean? That means that instead of it being opposite over hypotenuse, it's going to be hypotenuse h over opposite. That's cosecant. Secant, which is SEC, secant theta, is the same thing as 1 over cos theta. And what does that mean? Well, if cos is adjacent over hypotenuse, then secant is just hypotenuse over adjacent. And cotangent, which is COT, is the same thing as 1 over tan. And that's tan is opposite over adjacent, so this is adjacent over opposite. So here, if I have sine of 0 is 0, sine of 30 is 1/2, sine of 45 is 1 over root 2, sine of 60 is root 3 over 2, and sine of 90 is 1. Where did I get these values from? Well, if you remember from yesterday's lesson, we did special triangles. And if you remember special triangles, we know that we have a 45-degree angle triangle, which is 1, 1, root 2. And you know that we have a 30-degree angle triangle, 1, 2, 3, and then the 3's in the 30 and the root 3 are next to each other, 60 degrees, and the right angle triangle. So sine of 30 is, remember, opposite, which is 1 over 2, hypotenuse. That just means that cosecant is 2 over 1. 2 over 1, which is 2. They just wrote 2, but I want to show you the actual ratio, the fraction, so it's easy for you to see. So 2 over 1. Sine of 45, well, we know sine of 45 is opposite, which is 1 over root 2. That's 1 over root 2. And we know that cosecant is going to be the flip of this, so root 2 over 1. We know sine of 60 is root 3 over 2. Check. And we know that cosecant of 60 is going to be 2 over root 3. It's just the flip of the sine variant. And we know that sine of 90 is just 1. Because if you look at the unit circle, y over 1, and it's 1 over 1. This is also 1 over 1. Cos of 0 is 1. Cos of 30 is adjacent, which is root 3 over 2. Check. Secant is 2 over root 3. It's just the opposite. It's just the flip. And then cos of 45 is 1 over root 2. Check. And this is just root 2 over 1. Cos of 60 is 1 over 2. So this is just 2 over 1. And cos of 90 is 0. That means secant of 90 is 1 over 0. And you can't divide by 0, so it's undefined. So be very careful with that. And then we have tan of 90 is 0. That means cotangent of 0 is undefined, because this is technically 0 over 1. And now here, if you flip the fraction 1 over 0, you can't divide it by 0. Here we have 1 over root 3, so root 3 over 1, 1 over 1, 1 over 1, and so on. So very straightforward. The three new trig ratios aren't new, they're just reciprocal trig ratios. And you're going to get questions on these reciprocal trig ratios now. So here we have a point. Negative 9, 12. So x here, y here. Negative 9 is obviously here, and 12 is up here. So negative 9 and 12 is the point. And we have our terminal arm that goes to that point, and we make our triangle. Remember, the triangle always towards the x-axis. The height is clearly your y value, which is 12, and your base value is clearly your x value, which is 9. And we have our angle here, which is your beta angle, because it's the related acute angle, the angle inside. We don't know r, which we can solve for r. R is obviously going to be 9 squared plus 12 squared is equal to r squared. And we want exact expressions, so we do not